guys, welcome back to Advanced Algebra 2. Today we're going to be covering 2-4 complex numbers and operations, and you'll start taking notes on page 83 in your workbook. Before we get started with 2-4, I think we should spend just a minute reviewing how to simplify radicals, because that is a skill that you're going to need to use this section. So simplifying radicals. And let me show you what I mean by that with an example. So let's say I have the radical, the square root of 75. Now if I grab a calculator and I take the square root of 75 with my calculator, then I get a really long decimal which shows that the square root of 75 is an irrational number. So I can't just write square root of 75 as a decimal. I also can't round it because it takes away the accuracy of the answer. But what I can do is I can simplify it so I can work with it in combination with other numbers. So the way that you simplify radicals is first, number one, you're going to rewrite as the product of the largest possible perfect square and the remaining factor. So I think about the square root of 75, and I think about the largest perfect square that will divide evenly into the square root of 75. So I'll write that as the square root of 25, because 25 is a perfect square and it divides evenly into 75, times 3. Now 25 times 3 means the same thing as 75. It just looks different. So I'm just changing the form. I'm not changing the meaning, I'm just changing the form. So step 2 is you're going to take the square root of all possible parts, or all possible factors. And when I say possible, I mean take the square root if you can get a rational number whenever you take the square root. So if I take the square root of 25 and I'm going to take the square root of 3. Well, the square root of 25, I need more space. The square root of 25 is 5. The square root of 3 is a decimal, so I'm going to leave it as the square root of 3. So the square root of 75 simplifies to 5 times the square root of 3. And I'll show you a real quick one more example like that. The square root of 32. I can rewrite that as the square root of 16 times 2, because 16 times 2 is 32, and 16 is a perfect square. So then I can take the square root of each factor. Whoops, I'm ahead of myself. The square root of 16 times the square root of 2. The square root of 16 is 4, and the square root of 2 is irrational. So this square root of 32 simplifies to 4 square root of 2. Now keep that in mind, and then let's go to page 83 in your workbook. All right, page 83, usually we skip the exploring reasons, or at least we have been a little bit this year because we use this in class for discussion, but I've had a hard time figuring out how to do that. But let's talk about complex numbers and operations, and we're going to start with this exploring reason. So there's a math class played a game called Solve It, You're Out. At the start of each round, students chose a card from a deck marked with integers from -5 to 5. When an equation is shown, any student whose card states the solution to the equation is eliminated, and 5 students remain. So here's the 5 students: Mercedes, Steve, Aubrey, Elijah, and Fatima. Now I'm going to go ahead and say there is a typo in the text. There's been some confusion between this kid named Darius and Elijah. So we're just going to go ahead and change Elijah to Darius. because otherwise they'll be asking about Darius and we'll be like, who's Darius? Anyway, so the next equation was presented. It said x squared equals 9. Which student or students was or were eliminated? So I need to think of x squared. So when I ask for this answer to this, I'm asking what number squared or what number times itself is equal to 9. Well, I know that 3 times itself is 3 times 3, and 3 times 3 equals 9, so x could be 3. So that means Fatima was eliminated. Are there any other possibilities for x? Well, negative 3 times itself is 9. So x could be negative 3. So there are 2 solutions here, and Mercedes is eliminated. So whenever you have a quadratic equation, this exponent tells you how many solutions you can have. Whenever you have a polynomial, the highest exponent tells you you can have up to 2 solutions. Now, if I were to solve this by hand, I would have x squared equals 9. Then to undo a square, I can take the square root of both sides. The square root of x squared is x. The square root of 9 we just saw is positive 3 or negative 3. So I'm going to use this symbol, a plus over a minus. And so will you say that out loud as plus or minus? Or you could also say positive or negative 3. But that way we don't have to write positive 3 and negative 3. So x equals, that's an x, plus or minus 3. In the next scenario, in the next round, the equation was presented x squared equals negative 4. Darius thought he was eliminated, but this is not the case. Explain why Darius was incorrect. Well, let's see. Darius has negative 2. So let's take negative 2. Is negative 2 times negative 2 equal to negative 4? No. Negative 2 times negative 2 is positive 4. And positive 4 does not equal negative 4. So yay, Darius, you're still in the game. Cool. But this is math class, so we still have this. What? We have to have an answer for this equation. Okay, so it's not negative 2. 2 times 2? No, 2 times 2 equals 4. So 2 isn't the answer. 2 times negative 2? That equals negative 4, but I'm not squaring anything because these are 2 different numbers. We have an equation that doesn't have an answer. Is what mathematicians said many, many years ago. So you know what those mathematicians did? They made up a new number. They invented a whole new number. And they called this number, I have a special pen for it. They called this number I. And I is defined to be the square root of negative 1. And we refer to I as the imaginary unit. And I am using my magical unicorn pen to write about the imaginary unit. And if you are looking at your computer screen being like, what? Now they're just making up imaginary numbers? Yes, they are. But that's okay. We're going to work with it. Now, the reason that the imaginary numbers have to exist is because there are scenarios in real life where problems like this do happen. And because it's a real life scenario, there has to be a real life solution. So the math has to wrap around whatever's happening in that scenario. So you'll see this pop up in electronics. Electrical engineers and then electricians use the imaginary unit a lot, except I think they call it J instead of I, because I think they use I for something else. So anyway, I is defined to be the imaginary unit. So we're going to use that today in our lesson. So flip the page. Let's do a couple examples. So example 1, solve a quadratic equation using square roots. And we've got similar examples. So x squared equals negative 5. So what I'm going to do is I'm going to take the square root of both sides. The square root of x squared is x. The square root of negative 5, we're going to handle this another way. And by the way, anytime you take the square root in an equation, you need to write a plus or minus. So and let's write that down. Anytime you take the square root of both sides of an equation, we need to use the plus or minus symbol. And the reason we use it is because if you look up here, we had two answers. So we'll have plus or minus 3 here. All right, so back here. All right, so now I need to handle the square root of negative 5. So the square root of negative 5, I don't have any definitions for that. So I'm going to rewrite the square root of negative 5 as things that I can take the square root of, as factors of it. So I'll rewrite the square root of negative 5 as negative 1 times 5. So, and don't forget I need a plus or minus here. So x equals plus or minus square root of negative 1 times the square root of 5. And then we've defined the square root of negative 1 to be I. So x equals plus or minus I square root of 5. And the square root of 5 is irrational. So my final answer is x equals plus or minus I square root of 5. If I look at part B, x squared equals negative 72. I'll take the square root of both sides again. The square root of x squared is x. I'm taking a square root, so I'll do plus or minus. And then for 72, I'll rewrite it as the square root of negative 1 times the square root of 72. So x equals plus or minus, the square root of negative 1 is I. The square root of 72, I can rewrite the square root of 72 as the square root of 36 times the square root of 2. I can simplify that. So x equals plus or minus I. The square root of 36 is 6, and the square root of 2 is irrational. Now, I6 square root of 2. Now, that looks a little bit, to me, I don't know if it looks weird. Maybe the whole thing looks weird to you, honestly. But you usually see the 6 in front of the I, so I'll just rewrite my answer. X equals plus or minus 6I square root of 2. Okay, so then let's see. The other thing you're going to need to be able to do is going to be in the next video.